Imagine hearing about a computer that can be 0 and 1 at the same time, and wondering how that changes anything in your life. Well, this feels like science fiction, but it is real and quietly underway in labs around the world. And it has the potential to reshape medicine, security, climate science, and more. Quantum computing uses qubits that can exist in multiple states at once, thanks to something called superposition. In classical computing, a bit is either 0 or 1, but qubits can be both at the same time until you look at them. This allows a quantum computer to explore many possibilities at once rather than testing them one by one. Then there is entanglement, a strange but verified phenomenon where qubits become linked so that the state of one instantly influences another even if they are far apart. Think of it like two coins that always land the same way no matter how far apart you flip them. This combination of superposition and entanglement unlocks a kind of parallelism that classical computers cannot touch. Quantum computers are not just faster, they think differently, and that opens doors to solving problems previously out of reach. That starts with medicine. Imagine accelerating drug discovery by simulating complex molecular interactions that are too heavy for even supercomputers. Current breakthroughs suggest quantum systems could shrink development cycles for new treatments, and even enable real-time tracking of viral mutations or designing vaccines for emerging threats. The other big story is security. Today, our data is protected by encryption that relies on hard math problems. But a powerful quantum computer could crack algorithms by breaking down huge numbers fast. This threatens everything from your bank account to national secrets. But it is not all danger. Quantum safe, or post-quantum cryptography, is already being developed and standardized. By 2024, the first post-quantum encryption standards were released. The goal is to replace vulnerable systems before quantum computers reach the power to break them. Climate and networks is where quantum really flexes its muscles. It could model weather patterns and renewable energy grids at a level of detail we can hardly imagine. This could mean better storm forecasting, smarter energy distribution, and even finding new materials for batteries or solar tech faster than ever before. Finance is in the game too. Banks and investment firms simulate complex market risks. Things like portfolio optimization, Monte Carlo risk modeling, and fraud detection could jump ahead thanks to quantum algorithms designed for speed and precision. Of course, quantum computers are still early technologies. They are notoriously fragile and error-prone. Environmental interference can cause them to lose their quantum state in a blink, which is why much of the work today is about stabilizing qubits, extending coherence times, and reducing errors. When will you feel quantum computing in your daily life? Probably not in your pocket, but through cloud services offering quantum processing for specific tasks. Imagine smarter diagnostics, faster drug research, ultra-secure messaging, and real-time weather prediction. The world is quietly preparing for quantum-safe systems, and by then, this technology may already be reshaping so much of what we take for granted. If you had access to quantum computing, what is the first real-world problem you would want to tackle?